So greetings everyone, I'm Professor Kunchur and this is Physics Part 2. So physics is generally divided into Physics 1 and Physics 2, often with more interesting names like 201 and 202. No matter, the star equation of physics is undoubtedly F net is equal to ma. So as you probably know, the ingredients in this equation, the force, the mass, and the acceleration, these things are called physical quantities. So physical quantities are physical properties of physical objects and processes that can be measured. You can think of physical quantities as the cast of characters that tell the story of physics. And in Physics 1, by far the highest paid actor is force. You can think of force as the Taylor Swift of Physics 1. So in physics, we like to make a connection between cause and effect, be able to explain why certain things happen. So to that end, force is the cause of acceleration. So if you have an object sitting on the table minding its own business, there's no acceleration, we conclude there's no net force on it. But if it suddenly starts to move and accelerate, that means there's a force acting on it. So force is the cause of acceleration. But what's the cause of force? So going one level deeper, let's look at the causes of forces themselves. Let's take a look at this free body diagram. So when you solve these free body diagram type of problems, you have to look for all the forces acting on each object. So basically there are two rules that give you those forces. One is anything that touches it, that has a contact with it, can potentially exert a force. And then you can have force without contact caused by fields, force field. So if you look over here, the table is touching it, is supporting its weight. So as a result, there's a contact force, Fn, on object 1. Also the table may have, the surface may have some friction. So you have this friction force, F of little f, on object 1, acting to the left. What else touches it? You have the string touching this object, attached to the object. So it can pull on this. That gives you a tension force, Ft, on object 1. And then finally, this is the force field. Gravity can exert a force on an object without any contact, and that's the force of gravity on object 1 acting downward. So that's the point, that's the force field. So these are the two main reasons for contact. Now in Physics 2, we introduce additional fields such as the electric field and the magnetic field. These will also exert forces over a distance without any contact. Technically speaking, even the contact forces do involve field, but these are short-range force fields. So as a result, as far as the eye can see, if the range is less than a micron, it's basically a contact force. As I've seen in Physics 1, in the case of gravity, you let go of an object, it gets pulled by the gravity of the earth. So that's a non-contact force caused by a force field. Here's another example of a force field, magnets. So here's a magnet over here. Here's the second magnet. So let's put this next to it. If I bring it close to the other one, you see, the first magnet moves away from the second one. There is no contact. There's quite a bit of space between them. So similarly, you have the electric field, which can exert forces over a distance. So let's look at this demonstration now. Okay, so here is a piece of aluminum foil tied by this polyester string. A very, very expensive polyester string, by the way. See, 4 for $1. And now I'm going to charge this comb. So this is a plastic comb. I'll run it through my hair. As combs are meant to do. And let's see what happens over here. You see how it was able to pull with no contact. So this is an example of another force field, the electric field, that can exert forces over a distance. So there are certain similarities between gravitation and electricity. In the case of gravity, you have one mass, for example, the mass of the Earth. This creates a field around it, the gravitational field. And a second mass in its presence, the moon, for example, feels an attractive force towards the Earth. Similarly, when you have the charged comb and you bring another charge here in its presence, the charged comb creates an electric field around it. And another charge in the presence of the electric field feels a force towards the comb. There's one important difference between gravitation and electricity. In gravity, there's always just one kind of a force. It's always positive. There's no such thing as a positive and negative mass. There's only one sign. And the force is always attractive. In the case of electricity, you can have a negative and a positive sign. And accordingly, these can attract or repel. So in the case of the comb brushed through the hair, it has a negative charge. If you bring another object that's positively charged, the hair, for example, is positively charged, the hair gets pulled towards the comb. That's why the comb has a tendency to stick in the hair. On the other hand, if you have the two charges of the same sign, they will repel instead of attract. So if you look closely, one comb repels the other. It's not a dramatic effect, but nevertheless, it is noticeable. The same is true about magnets, by the way. They have poles, North Pole and South Pole. So you don't always have attraction. You can also have repulsion. So look at this. One magnet without any contact is able to push the other one. Force field acting through a distance. Also, this force, the field, it goes through a material like wood. So here's a little piece of wood over here. So look at what happens. You see, the wood is not able to block the magnetic field. But if I flip the magnet so that the pole is flipped, see what happens when I bring them close together. You see? So here also you have two different poles. So that's one of the major distinctions between electric charge and gravitational charges, which are masses basically. You have only one kind of mass. It's always positive. You always have attraction. In the electric case, you have two different signs. You can have attraction, as you saw between the aluminum foil and the comb. If you have two combs, they're the same sign chart. As a result, you have repulsion. So this first chapter in Physics 2 is basically going to focus on electric charges, electric fields, forces between them, and stuff like that. So before you go on and get into the details of that, you might want to pause the video, go through everything we've just discussed, make sure you're up to speed. And so then you can then continue into the more detailed structure of this material.